We are hosting our very first official episode of our tech series. And this episode, along with 2 others, will serve as the foundation episodes to give you a view and a bit of context into what is the Ecosystem AI prediction platform. Today's one I'm particularly excited about. We'll be talking about AI architectures, particularly how ecosystem fits into them and who we are in relation to a lot of this, and ultimately what is the architecture of Ecosystem AI itself. Jay, I'll hand over to you.
Thanks, Jess. It's difficult to create only one foundational session, but the intent is of the day, at least, is to just talk to the architectural perspective that is needed to be considered when you think about taking AI tools from some kind of data environment into production. The challenge is that there are multiple processes, and we'll probably talk about those in following sessions to get each one to work. But for today's purposes, the big focus is to understand how all of these pieces come together. Almost all of what we do is available in various forms. So in technical repos, and especially the open source libraries that we've published over time, we have aggregated from ecosystem account, private accounts, and so on, all of it under our main business. It's called Ecogenetic LLC, but you'll see that it is essentially the Ecosystem AI is our go-to-market brand. So you'll see that all of the communication sits around that as the primary focus. The repos are broken up into various categories, and I'm going to talk you through those architectures in a moment and where they can be applied, especially the ones that are publicly and freely accessible versus the ones that are private. So there are only a handful of repos that we keep private, like most software companies, in a space where the algorithms that we invent and that we do continuous research on that sit in the core is retained in one area, but anything that we know will benefit our community or that people can use is made accessible. The repos that are accessible cover on the one end your scoring engine. There's a library you can use with our real-time engine where you can extend it. So we have created architecturally an extensible framework. So there's an extensibility capability. There are also custom GPTs that you can use to help you build some of that extensibility. So if you go to like OpenAI's custom GPTs and you go search for some of our technical assistants, you'll see code examples and everything that is accessible also through the repos are available there. So you can accelerate whatever you want to build to make sure that you can get especially real-time inference into production, because that is at the heart of our business, how you realize value in the context of an AI capability. You realize it by making sure that there's an inference capability that is incredibly fast and that can dynamically select if something is either accurate and precise all the way through to being linguistically generated or using generative capability. So that means the conversation around, do I want to go fetch a value in real time that is a score that represents a person's probability of defaulting or performing a transaction that is fraudulent, or a recommendation around what offer you're going to be taking up next, what your nudge is, or what message banner is going to appear on your phone, all the way through to what language can I use if you're a happy person. Each item is a separate way you would want to approach the way you use it, but you want to have a reliant architecture end-to-end that can implement all the capabilities that are needed to get these things implemented. So we believe that we've created that architecture over the last number of years. We've stress tested it at scale, and we've now made those repos available that deals with the scoring engine. The challenge with the scoring engine, by the time you get to use it, is that you want to make sure that you've got scaffolds that you can use. So you want to be able to take examples and then access a scoring. So if you want to go to an app and type in a customer number and get the engine behind the scenes to score a customer's personality, go fetch the messages for their personality, return it back to the front end. There are apps like that available that we've published. So we have got it done in Python, we have it in React and in Angular, we have it in iOS, we have it in Android. So there's a whole series of repos that cover a bunch of examples that are pre-built that people can take and they can go do something with it. We've also recently added 2 chat apps, and a chat app that is essentially working similar to how you would use a ChatGPT on an iPhone or on an Android device. And it has a backend connecting capability to one of our servers or our server. You can register and connect with it, and it has access to our own LLM infrastructure that we host in our data center. So that means you can get a 5.4 or a Llama 3.2 or a DeepSeek 32 billion parameter. Any of those models are accessible through a chat so people can see how these things work. It also has access to our Ecogenetic framework that maybe we should cover at following sessions to when we talk about the architecture of the broader agent-based framework that is needed to make an agent system work, get deployed. So I will get into it in a bit of detail today as well, but let's just think about that as something we're going to handle in the future in a lot more detail. The other thing you'll find is if you go to Docker Hub, we have, I think, 22 or so publicly accessible containers. The containers that are core to our business, including our server, requires a key that you will get from us. The license agreement for our product is essentially designed around the style of license agreement in the context of how you deploy it in your own architecture, that if you use it for experimental, for research, for sample capabilities, then there's no license fee. The moment it's used in a commercial business, then there's a commercial license that applies. So that means that it's not completely open source in its core, but the periphery repos and so on we've made accessible. So that means the containers that relate to us normally would require some treatment that you're going to have to think about from a licensing point of view. But then we also built a number of containers that you can deploy in your own cluster or in your cloud cluster that deal with H2O, that deal with some of the pipelining tooling that we're using, like Airflow. We also have a Grafana, we have an Olama. So we manage a couple of those containers that we know a company would want to have in place to manage its own technical life cycle end to end. The idea behind an ecosystem of technologies is kind of where our name comes from. We specialize obviously deeply in our own tech that we work on. Anything that we believe that we cannot do the best in the world, we get out of. And that means we know we compete with some people about some of the things that we do, and we know that we're better than people in our space. We believe we are, as I guess you have to be. Let's take an example like Superset, the front-end dashboarding tool built by Airbnb that is about 4,000 developers globally working on it, and you have continuous updates and upgrades, and we participate in that community. Why would we want to build our own front-end dashboarding if we can participate in that community? We provide tech capability, support, and the like, and we don't close anything down. We don't lock it down so that you don't get access to what happens behind the scenes. That's the key to note architecturally about how we approach anything in the architectural space. All of what we do is open at metadata level. Some of the algorithms are fairly private, but there is no arbitrary lockdown or encryption that happens so that the client cannot make use of it in its entire value in the context of their commercial business. And obviously our focus is to get as many commercial companies to participate in this as possible. We have a developer site. You'll see that on developer.ecosystem.ai, there are quite a large number of bits of content that you can gain access to that takes you through the entire life cycle of how you could build something. You'll see that it's got the classical quick start, local setup, and the like. But the big thing is that when you want to set up a local install on your own machine, the environment we've created and the way we've set up the compose scripts for if you run Docker or Podman, you won't have licensing with Docker Desktop, but you'll be able to run an entire free containerized environment. You know that we've got enterprise clients who run Podman, so there are scripts for that too that you can spin up in a containerized environment. All those containerized applications allow you to scale horizontally. And we've spent a lot of time making sure that the core architecture of the product is horizontally but not vertically scalable. And the reason we do that is that you don't need to scale in the context of the size of the memory, the tin that you have. You can scale across horizontal architectural nodes to make sure that you can get your deployments right. So even our large enterprise clients would spin up multiple runtime nodes in a Kubernetes cluster, and it will dynamically scale depending on what the loads are. So that means it's got all those capabilities kind of pre-prepared. So the idea is that you can clone a repo from, let's say, GitHub. Each of these repos contain all the scripts needed to run your product locally end to end. We have for all of our deployments, both ARM and x86 and AMD deployments. So you'll see that they've been tested. We tested all of this infrastructure across the different cloud architectures that are most prominent. We do know that the ARM capabilities are quite different and far cheaper and far more powerful than what happens a lot with the x86 kind of architectures, even though there are some movements in the space. But they are contained and built to deal with all of those architectural styles. You'll see that when you look at how the core components are assembled, everything in the ecosystem kind of revolves around the server as a core connector to many of the capabilities. So there's a server that is the heart of what happens when you run any of the technological components that fit around the periphery. So that means that the server itself is entirely headless with no UI whatsoever other than a Swagger front end. If you go to, let's just say we take, like one of our servers that is a public demo server, and you go to that server, you'll see that the prediction server is with a few hundred microservices, and these services all are accessible, depending on where you've obviously configured it, but mostly, even if it's public, you can access those once you've generated your key. So you need a JWT key that you either create in your own server through a Workbench front end, or you generate it through an API, or you generate it through a tool that you might have as a pipelining tool. So let's say you've got an Airflow pipeline, and you want to run an algorithm, do some data migration, use our pipelining capability. You can access that entirely headless. That means everything we explain that we can do is accessible from a non-UI-based capability. We do have a CLI project, a command line interface project that we're working on. We use it from time to time. Not many people use it, so it is a bit stagnant at the moment. We'll keep addressing questions about people using CLIs. But we basically see that Python and front-end Workbench kind of capabilities is what most people kind of are interested in. The server itself normally gets hosted in some core place. The server is also where you'll set most of your settings that deals with, let's say, your generative connectors, if you want to set those up. So like in this case, if I tell it that I want to have an open API key or an open AI API key, or I want to set other settings, an example, let's say I want a setting like I've got in a local environment here called the chat server. You can point that chat server to an OpenAI server, to a Grok server, to any server, and we've got a full implementation of a layering capability inside the ecosystem environment that can abstract your AI layering depending on how you've configured it. So let's say that you spin up a cluster in your own business, sitting on a GPU or an ARM infrastructure, depending on how it's configured, and that's what it's supposed to do. You've got another cluster that deals with the data that it's going to access for the vector store. If you run ChromaDB or OpenSearch, all that happens in our world, you'll point this to that server, and all of those capabilities can then be audited, tracked, logged, and you then have a capability through our interface to have different styles of engagement. And I'll show in a moment what those really mean. By the time you configure your server and it's running, and you've assigned, and you can, here you can see it's not assigned, but you can assign additional memory, you can change port numbers. So everything about its configuration is accessible through environmental variables, including its security settings and its database that it connects to for user authentication. And you can decide if you set it up in a database or run the one that's in our environment. All of that is configured. There is also a setting that you can't see that's present here, but a setting that you can tell it what cloud environment you are in. In the Workbench, it will then adjust how you interact with some of it. So if you run on GCP, AWS here, Prem, or on your local machine, there are different settings that can apply that you can also then update or obtain from the configuration that we call the backend server. Once the server is up, the Workbench waits for the runtime just to start up so that you've got a total non-visual environment running, and then the Workbench connects to that server. The Workbench can be configured to connect to, let's say you've got in an environment, a server that you've configured for the people who do, let's say, forensic work, and people who do sales work, and people who do IT operations updates or whatever it might be, and they want to have their own separate environments for their AI projects. You can take our server and configure it. Either there's a central server pointing to different databases for different metadata, or you can physically separate those environments, and you can take one Workbench that can then connect to any of those servers. That means the user interface is completely separate from what happens in the headless environment. The other things you can do, the notebooks container is the one that runs a Python stack. There are two key instances that run. One runs a whole Jupyter notebook environment. So you've got a notebook server that gets spun up. We find that many clients run their own notebook servers because they might run their own configurations, so they don't have to use ours. You just point and map the structure where your shared projects are onto that particular notebook server. But we do have a Python stack that deals with data transformations and AI work that is built into the notebooks container. If you install this in, let's say, a fully deployed cluster, and you want to scale the AI, especially the AI components of the Python stack, you might end up spinning two notebook containers, one that deals with the Jupyter notebooks that a person can use in the front end, and another one that then runs on horizontal, scalable with maybe different computer memory requirements. That's completely configurable. And that's why you see that there are two ports here that is accessible, because there are two different processes that you might need. So you might start up one where you don't run, let's say, the Jupyter notebook, you only run our port 8010. That will then deal with that capability. So what that looks like, if we just go to, let's say we go to me backend, so you'll see here that the notebook server runs simulations and other things. It's got a whole lot of capabilities around the journey and the agentic work. It's also got a whole LLM capability with this text to SQL, chat to SQL, LLM backend. We've got a Python generation backend tool that can sit within a separate thread that you can then make obviously accessible depending on how you configure it in whatever scale you want to deploy it. The heart of the scoring and where you spend most of your time scaling out is through the ecosystem runtime environment. So you'll see here it talks about runtime solo. So it means that it's got a Mongo instance embedded in the kernel. So you can spin up that engine entirely on its own without a server or anything being around it. If you started up with let's say no case configured or anything like that, it uses about 250 meg memory. By the time you scale it, you can decide how big that memory requirement is based on what kind of work it's doing. So if the job of the scoring engine is to go fetch a customer's data records to load 5 or 10 models, it's going to experiment with additional offers, but it loads a very big offer matrix. You just need to calculate your memory load based on how the dependent data will appear in memory, because that gives you the performance. So that means that if you want to get a 1 or 2 or 3 millisecond turnaround time on our runtime engine, and you don't have the memory allocated properly, then you're probably going to end up with some kind of performance headwind swapping happening in the setup. So that means that we see that in some clients who run very large cases, that memory configuration on a single container could be 4 gig. But if you run it in a basic environment, sometimes 100 runtimes. And it easily runs within my 32 gig allocated. So you can decide how to set this up, and you also restrict memory with another parameter that's not visible here, but you have got a whole lot of parameters you can set that obviously then determines the behavior. The other thing that happens in real-time AI or real-time recommendation systems is you want to be able to set the back-end looping update cycles if there are algorithms that require that. So we have got a number of our dynamic algorithms that require a setting to be set as to how often the model needs to calculate an option store based on offers that are presented. And that option store normally depends on some kind of distribution or a weighting system. It's set at 60 seconds, and then the others are set at 800. So you might want to set, depending on what your project is, any of those settings when you spin up your cluster. It's got a big impact on the algorithm's performance, depending on what the algorithm's need of convergence is. So if you run a probabilistic algorithm on a common model where there's no customer convergence, and you wanted to converge on, let's say, a banner on a screen or whatever the scenario might be, it relies on the option store to determine the preferences over time. So you can set it based on how often you think that will change. As soon as you set, let's say, probabilistic algorithm on a customer level, then it will build the model in real time. So your compute requirement and your memory requirement might be dependent on how many options there are that it has to work through. If I have, let's say, 10,000 options, and I want to only pick the top 10, the compute requirement still can train the model in real time, typically 20 milliseconds. The model is then inference capable at about 3 milliseconds. When you start scaling it and you add eligibility rules and you add, let's say, some kind of value function calculations, or you add lookups additionally to what you're doing, then the capability might then shift into a different requirement. But that means that you can kind of equate runtime to use case. So there's typically one runtime per use case configured, and each runtime can scale horizontally. You can spin up as many as you like, and depending on how you configure it, you can decide how you deploy that. If you want to run it on your local environment, what the architecture would require, and here's an example that has been commented out, and let me just uncomment this so everybody can get a feel for that. So what this does is that it runs this environment and it sets up what's called replicas. The moment you configure replicas, this replica will then spin up as many runtimes as it would need to, depending on your performance criteria, and you can decide what your performance criteria would be. But like here, you can set the amount of compute or CPUs or whatever you might need for it, depending on what you want it to perform at. The critical thing is that you configure your properties file to be locally mounted. As they spin up, they must be able to read the same content, so you don't have inconsistencies around how the configuration gets set up. But that means that you've got different options to configure that. Yeah. So you see that out of the box, normally we spin up 7 or 8. You'll see, like in this case, it shows 7 different runtimes that are spin up that you can run on your local environment with everything else normally would run alongside it. If it's not doing anything, then it's pretty low key and it doesn't use a lot of power. So if I look at this machine here, you'll see that Docker does take most of my power that I run on this Mac. If I just look at the Docker process, this is what I'm running on this machine at the moment. I'm running massive cluster infrastructure with Superset, with Presto, with all of our chat interfaces and a chat engine, and I'm running a Llama language model capability. And that means if I look at, like all the models running behind the scenes, I'm running Mistral and Llama and all of those on the same. So we really want to make sure that if you want to set up local infrastructure and you've got an M4 or an M3, you'll be able to configure those yourself in a local environment.
If you're running that on your Mac, what GPU do you have?
You don't need a GPU. On a Mac, because a Mac M4,
the M4
series, okay, they use what's called contiguous memory. If you look at this particular machine, it's got 32 gig or 36 gig of memory, and it's an M3. This machine is 3 years old. If I had to run Llama 3.2, that is not that big a model, and I ask it, explain cloud architectures to me, you'll see that it is instantaneous. On this machine, maybe a 30 gig model, that could be a 24 billion parameter model without any degradation. If you wanted to do this on an Intel machine, you would have waited maybe 2 hours to get the same job done. So there's a profound difference in performance if you run the ARM-based architectures. And that's what the M is. It's any ARM architecture, even in our cloud environments, what Microsoft and AWS and everybody is doing because we're partners of those companies, are trying to force us to move our marketplace apps onto ARM because it uses less power and it's way more performant for this kind of work compared to the classical x86 architecture. Yeah, so that's, yeah.
So what you're saying is I need to sell my gaming PC and my NVIDIA GPU and get myself a Mac.
Well, why are you asking?
No, it's quite impressive. I constantly saturate my GPUs on the smaller models.
Yeah, and you know what is interesting about the Apple scenario is that it was entirely by accident, it seems, because it doesn't seem that Apple designed the architecture to be deliberately memory efficient when it comes to matrix math. And it turns out that when people started running models, especially, I don't know if you run Ollama, like we run Ollama locally, and I can run any of these models, doesn't matter if I'm flying or traveling, are very, very performant. If you look at, we've got a slightly different configuration. If you had to look at the performance of this kind of architecture on the Mac Mini, if I just share my screen from somewhere else, it should come up in a second. So if I had to take, let's say, one of our chat apps, and I want to use the ecosystem chat environment, and I go check in. By the way, this app is available in the App Store for free. You'll see that this uses api.ecosystem.Ai V1 chat completion. So we've got a full front-end chat completion API that can intersect messaging, that you can turn logging and everything on. On the app, it doesn't do it for this implementation because we don't want to know what they're talking about. It's really just for demonstration purposes more than anything. But you'll see that the models that normally run here is the Mistral, and this Mistral model is the one that is very good at imaging, DeepSeek R1 and 5.4 reasoning from Microsoft. Their brand new model is a pretty good model. So that means if I go in here and I'll just say to it, hey, how are you? And you want to take a model like that is trained on Facebook data, you can see the performance that it got. And this runs on a Mac Mini with 32 gig of memory. on an M3. So that means not even M4, it's not even the top configuration, and the performance is, we found, very, very good on those kind of architectures, especially for the implementations that we've seen now, because I know there are data centers that are available in California that you can rent essentially Apple equipment. So people have been buying up second-hand Apples everywhere. You can't find anything anywhere. The moment it comes available, some data center person will buy them up and stick them in their center, and it'll continue to work. Because I think our oldest computer in our data center is about 5 years old. It's never been shut down, never had anything, and it just goes on. So it is a good architecture for not having to worry about paying licenses for operating systems and the like, because it's all included in your purchase. But yeah, so that's kind of the concept. What happens when you then spin this up, the other thing that you'll see is ecosystem Grafana. We have a Grafana instance that comes with a pre-configured data connection and everything set up. So if you run any kind of Grafana environment, and this is if I go to, let's say, the Me Grafana, one of our installations, and I just want to take you to the data connector. So you can run any kind of cluster that you like, where you can run your dashboarding, depending on what you want to configure. But if I go to connectors data source, you'll see that we use ecosystem server JSON API, and this JSON API connects to the ecosystem server in the container. So that means you can connect all of the reporting and everything you need in your Grafana to the ecosystem server that then connects to the databases and route all the traffic for you. So that's why it's quite core that you have the server installed with the right configuration, right memory as the priority. Because if that's in place, everything else works around it, because everything can connect, can connect it. We're also big fans of, and you'll see here that the reason why it goes to our server using JSON rather than SQL is that we are big NoSQL fans. To give an example of a classic implementation, if we connect to an Oracle database, a Microsoft SQL database, and so on, the amount of time that it takes to do a count on any one of those databases compared to running our infrastructure is typically about 1 million to 1 difference in performance, give or take. So that means it will take 10 minutes to count 300 million rows on Microsoft SQL, and on Mongo it will take maybe 1 millisecond. That means the pipelining, memory capability is enormously important for us. That's also why you'll see that most real-time architectures, especially San Francisco-style implementations, will use a Mongo-style database that can deal with this high volume of inserts needed to drive your logging without having to do inserts across different tables. Where the insert time is that you do a single document insert, and you can extract a single document when you want to report on it. So that means that the NoSQL or the kind of unflattened structures that you normally have in documents, it definitely gives us a big performance increase. We also support Cassandra out of the box, so you can set up a Cassandra connection for more ring-based, especially if you think about when technologies or databases fail and you want the database to be self-correcting. It's by far one of the best to deal with that kind of scenario. The ecosystem manager is something that kind of happens depending on how volume, how you want to manage your volumes in your environment. So if you sit with something that generates, let's say, 50, 60, 100,000 transactions per second, over time, people find it difficult to aggregate those in real time. And that means that you then have to go through a whole ETL process to get it to do work. And we built this capability to aggregate continuously, that you can decide what the aggregation rules are, let's say at a minute level, especially in high frequent environments, so that you have an actual real-time view that's, well, not quite real-time, it's a minute in arrears. In actual fact, it's 3 minutes in arrears. It's 2 minutes for technical and volume cost and 1 minute that it's in arrears. And it makes sure that your dashboarding is essentially real-time, that you can see what's going on and it aggregates. So this is also kind of in the container. Our new containers will be updated hopefully in the next 2 weeks. Eric is here, so maybe we can talk about that if we need to. There's also an MCP implementation that all the runtimes work behind an MCP. So you can connect your MCP directly to your Claude instance and so on. If you go to MCP, the docs for that, so that is the model context protocol in the context of agents that can be bolted into any public tool that supports an MCP server can connect to our MCP and go pick up the doc from here. And you see here that there's invocations and response and all these kind of endpoints that are accessible directly from your favorite tools. So if I click on that there from a tooling point of view, you see here that it shows runtime. This ecosystem runtime MCP environment is now bolted into your Claude environment. And you also have exactly the same for OpenAI and for Gemini. So you can bolt our MCP implementation because it supports the public definition of what an MCP is supposed to be. So if I ask it here, what is the runtime configuration? So let's say that you had a Claude implementation sitting inside your cluster. Claude will do the language piece, but the data that comes back that it's going to connect to your own runtime will then go and perform this action and get results back depending on the questions that you ask. So that means you can then use, like in this case, it tells you there's the version, the date, the memory requirements that it's in the total server that it's running on the cluster, and so on. So that means you can set it up so that you can have language interfaces to our entire product through the MCP interface. And all of our endpoints are easily accessible through an MCP environment. And that just means you've got a native integration with your linguistic tools. The other part from the linguistic environment, if I go to Chat GPT and we go to GPTs that are published in the ecosystem, and I want to access something in the back end, let's say the technical assistant. This technical assistant is if you wanted to, let's say you want to build recommenders yourself and you want to go and customize or maybe build additional rules and other kind of things into our server, and I just explain recommenders to me, you'll see here that what it'll do, take the actual capability of a recommender would look like in our framework and give you an entire story about how to implement it. And that's what often happens with frameworks. We don't have to know much about our framework to get going. You can start from the outset and get things done. So that means the architecture must be designed that even if you use, like in this case, a public GPT, nothing in there, even if you share it, is really private because we're going to add 5 lines of calculation inside a runtime. In most cases, we find that it's so easy to deploy those and get those done that you can do it through a public interface like this, or you can do it through a local Claude or a local Llama, depending on how you implement this. The other thing is that if you ask it to write me a post-score dynamic recommender plugin that calculates upper confidence bound of the scores returned. Let's take an example and see what it comes up with. So what happens, you can literally ask it these kind of questions, and it will know where to go find, and it will explain to you, and then it will go find calculations and then do the actual work for you. It will then build the code, and this code here, com.ecosystem plugin customer, post dynamic UCB, this is fully compliant to take straight from here into our framework. That means all of these functions, options, parameters, options, feature store, all of these is what sits, and then it shows you where it added, like in this case, the example, and you can take this code from there, and if you wanted to implement it inside ecosystem environment, so let me go into one of these deployed projects. I want to do it through the user interface. I can pick one of these environments. If you go to plugins here, you'll see that these plugins that are selected that you might want to change, you can click compile, and in real time, there's a compilation process that gets done. So you don't have to run pipelines at all. So if you set this up behind the Python pipeline, the Python pipeline will automatically, and it's basically a 3-step process. You don't have to worry about the classical pipelining, and we call that permanently in production. Permanently in production means that you spin up the cluster, you have it available, the runtimes sit there waiting for you to either push new code to it if it's for Java. If it's Python and you want to change the front end, there's a Python component as well, so you can pick which framework depending on the performance requirement, and you can keep it in production by the time you push it. If you've got data sources that must be looked up, let's look at the data architecture for a second. You can configure the parameters from data source to go to Mongo, Cassandra, Presto, or an API, or to get data from another runtime. So you can set up your cluster that you've got a data API that must be accessible to pick up your customer record from Salesforce or your CRM system. You can configure that to fetch that value for you and then return it. The idea is that the entire architecture is like an ecosystem configuration, and then have ways in which they all get bolted together. Okay? So that means when you set up an environment like this, you have an entire AI capability configured from the outset if you set it up like that. The way we then kind of see platforms is that you want to be able to take an application that sits on top of a platform. Why do you want to do that? So that you can deploy it yourself continuously with your own capabilities. We have about 40 modules out of which about 11 of them, I think, give or take, 11, yeah, is exposed through our website. And the idea is that those can be used to set up any kind of functionality that you like. If you take how data platforms have emerged and how they integrate, the ecosystem environment is a vertical slice, essentially through the architecture, to bring all those capabilities into a single deployable environment. If you look at that in the ecosystem context, you've got the server that does all of the base work. You've got the workbench, notebooks, and the runtime. Those are essentially the essence of what you need to work with. There is also an ecosystem algorithms environment and container and repo that is also publicly accessible, that contain a number of different algorithms that can be configured in a Python environment. All of our backends that are headless, that all are headless except for the ones that are specifically designed for front ends, use OpenAI 3.0. So open, and I'll do a fix on the fly here, Jess. I know that that's probably not good for the, just use OpenAPI 3.0. If I go to the Swagger, you see at the top it says version 3 docs. That is what OpenAPI 3.1 looks like. We support 3.1. This definition is the core definition that can be used even in your generative tools. If I go to a chat environment and one of my GPTs in my company, and let's pick the one that calls one of our backend agents, you go to spend and money personality, that definition that you saw there gets used when you configure the way that you access the backend. If you look down here, you can see that OpenAPI 3.1 definition, and you can drop it straight into any tool and you can access the backend. If you want to drop that API into a cloud-based API, you can also configure it there. So it's completely configurable across different environments, depending on where you want to deploy it. The other part of it is that we use what's called a worker architecture. And a worker architecture means that we have very, very strict layering, where the way in which functionality evolves that we use will not affect the performance of our work. So that means that when TensorFlow or PyTorch or H2O bring out new versions, it doesn't affect the metadata that you've used to configure what you work with. So you evolve those independently so that they're not connected. So if we go back to that example that I had earlier, and I'll go look at maybe one of these journeys, and let's say we go look at the ecosystem agent environment, and let's pick what's the one that we've been working on, this telco sales one. That's the one that's on the app, and I'll show you in a moment what it looks like. Let's say I want to have a quick squiz at what this thing is about. I'll look at the node configurations, and the moment I want to know if there's a definition needed that is connected to some kind of cluster externally. You see there that's connecting to the server in this cluster, but that server could have been somewhere else in the world. This could have been configured to sit anywhere where it needs to scale. And you can set up your guardrails and everything to the Ecogenetic environment without worrying about where that server comes from or where it is configured. If you want to set up the runtimes, they use the same capabilities. You can configure them to sit wherever because the metadata is abstracted. Once this is configured, you want to know if it has been deployed properly. So this has got a standard functionality, standard capability in our runtime engine that you can call the config API, the ping API, the health API, all the pieces that you would need to check that it's running, that you can drop into a cloud environment too. So you could take our runtime and do a bring your own predictor or model inside SageMaker that will register it because it supports an open API definition. So you can move it wherever you need to go, but we know that these companies don't have real-time converged algorithms the way we do it. The behavioral science pieces we work on is unique to us. Push means take the configuration and make sure that runtime is made available. If it's in production, the architecture says spin up the cluster, and you can create a cluster in Kubernetes, so whatever the environment, or ECS or OpenShift, we've got scaffolds for all of those architectures, depending on how you want to configure it. Once it's spun up, and you know what that target URL is, it will know how to do all the treatments for you through the server that does the work. If I go to this agent configuration and I push there, this push pushes this entire journey's configuration to the service. This particular journey uses the server to pick up its chat node. There's an intent detection engine that either sits in our cluster or a generative model that uses an OpenAI definition, and we control the internal scaffolds to handle how you manage intent. Why? because I want to know if a person is going to buy, if they're going to sell, if they engage, if they ask for help, or if they're trying to hack the system. So there's always, wherever you go, a guardrail as to what I want to force not to happen. By the time I then run a reset to configure, let's say I want to take customer A, and I say, hi, you'll see that when it executes, it runs in the context of what this configuration was set at. If I want to run that same architecture, let's go back to the app example from earlier, and I go back to my app here, and I configure it. Ecogenetic is an option on the app. The Ecogenetic app means that it's got now two different options. It's got a fact injection architecture that you can connect to. The fact injection architecture can connect to your vector stores, to all of your backend generative capabilities, or you can pick Ecogenetic, and Ecogenetic is a journey. That's because a journey means that I'm now forcing you to go down step by step. This is say I take the ecosystem.Ai, and I save that, and I say help with a colon. Now what you see, what it brings back, it uses an entire generic API interface, but it's got its own set of rules, its own set of configurations. It's got a generic chat, but it's got a command line. If I want to ask it what configurations have been set up, in this, I just ask it for configs, it can pick up the configs. Now, let's say I want to go do a SQL-based connector. An intent detector normally will pick this up. And let's say there's bank customer there. You'll see it's this text to SQL environment. So I'll just say use bank customer. We'll come back and say that your configuration has been set. Now the backend, that the fact injection architecture was configured as a worker architecture. It's got two layers of worker architecture. One is the app and the APIs accessing that server, and the server then accessing its generative world, and its generative world accessing its vector stores. That is all separated depending on how you want to configure it. So if I ask it, how many transactions do I have? Now what it needs to do is not do generative model work. It needs to use the generative model to interpret my intent, take my intent and return me an accurate and precise result. So we see that there's quite a big difference between something being linguistically useful and being accurate and precise in the moment. And even if it's accurate and precise and linguistically useful, I want to bring those two pieces together into one journey. So that means you can ask how many food transactions, and you can ask any kind of question that needs to be accurate and precise. But for the sake of time, let's go to the Ecogenetic journey. Now what you see what I've done, I haven't given it the name of the journey, I haven't given it the config, and as you see here, it says use server connection. So let's say I don't log into the server. On the back end, you can configure, depending on where this is connected to. So let's see, this is connected to the me server. If you look at the server connection there, me server.ecosystem.ai. So if that is within your secure walled garden, you can get the app then, because it's freely available, connect to that server, let the person either sign in, and if they don't sign in, you can set up a default config as to what it needs to do if a person is not signed in. So you can set up a default public chat environment. Let's just take this one as a generic one and change our conversation. I'm going to say hi, and it should come back. Hey, John, welcome to this telco company. This is exactly what you saw, what I did in the workbench. The headless environment for a journey runs on the server that you can access, and it will know how to route whatever large language generative chat sequencing that you need. It also supports full streaming. So that means it streams the same way as an OpenAI's streaming environment is. If I ask it, well, what are some specials? It should come back and say there are a certain number of specials in this configuration. You see that time it's taking, and I'm going to show you in the server now why it's doing it. I don't know what specials is. I want to buy a device. Let's see what it comes back with. You can configure where you want that detail and the answer that it's going to give you, where that goes. That normally comes back from the different devices that are there. If I then say, okay, I want device number 2. Do you want to purchase this product? Yes, for this particular environment. So if you look at this journey, we would have gone down and picked a recommender for the device, recommender for the products, and those would have been done in the context of their scoring capabilities. And then the architecture will morph them back, and you've got all kinds of different types that you can use. So if you think about messages, recommenders, feedback systems, conditions, APIs, or generic chat nodes, breakout. The breakout works to WhatsApp, to call center agents, to whatever it may be. You can decide if you want the journey to have an augmented configuration, depending on its purpose. But that means the architecture then sits central. It communicates to whoever it needs to communicate to, and you can configure that to scale horizontally or in any direction, depending on what you want to scale on the back of that. And that just means that you normally would access the scoring engine or the server to get the work done that you want to get done. So there's a lot more that we can discuss about architecture, and I think that we're going to have architecture 101A and 101B, and the details that we might want to expose, because there are some ways in which we see total gen architectures being deployed and where we fit. And I think the other thing we're discussing is by the time you deploy it in a cloud environment with Kappa or Lambda architectures, that gets deployed in any one of the environments that you would use to deploy it. And we've got some unified patterns that can be applied.
Sorry, just a question. So this solution, can it be white labeled?
Yes. So the entire design.
Think of 1,000 use cases that can.
Maybe to give a quick example of the spend personality in the architectural backend, this is configured publicly. You can go to a public API and pick up this environment. If I go back to this config and I edit this, you see that it points to bank runtime 2 and bank runtime 3. You don't know who owns bank runtime 1 and 2, and this URL is assigned to the scoring engine. If I now go to bank.ecosystem.ai, and I want to see what this thing is going to be doing in the back end, the deployment that is deployed here is spend personality, money personality, and spend personality. There it says runtime 2 and runtime 3. So if I go to, let's say, spend personality, here is the spend personality's configurations, including its reward function, its post score, because this uses post score spending personality algorithm that's built into our kernel. And nobody on the front end knows, because this GPT was created with our name. This API definition, with how you call it, is entirely used by the company that uses it. Nobody really knows that Vodacom's just for you, or revenue models, or fraud models, or 100 other revenue cases. We're not a consumer-facing company. Even the app that's on the app stores, they are demos. That's why we publish the source code for those, because we're not in the consumer app business. That's not what we do. So that means you normally would bolt us into some kind of case, depending on what you want to do. By the time you want to configure this module, and let's say that you've done it in one of our environments and you want to deploy it, you go to your project and you'll see these are all the classes of assets that that entire module can be deployed with. And if you look at that core project in its own right, you'll see that it's got collections, files, prompt engineering. Oh, this doesn't it, but for network configurations, for feature stores. So that means the entire functional capability to make this module a product can be configured, and you decide what it is and what its name is, it is used for, depending on your application. That means everything about that capability can then be externalized. And then on the workbench, obviously, if you want to build static models or dynamic models and so on, we've got workflows that help you get those done so they are deployable. And then when you're done with that, you click export, you pick the project that you want to export, it builds a back-end engine for you, it will run as a job. And when it's done, it'll ping you, and then you can download that deployable package and move that anywhere. We often use it for testing and validation, pre-prod and the like before you put it into production. And you can then decide how you configure that deployment. So in this case, to show how this works, if I ask it for what is the spend personality score for customer 590, now what it'll do, it will detect the intent, because that's what almost all engines need to do first. It comes back and asks me to access the API. I'll set it before, don't accept it, so I can show what it looks like. It sets up the parameters. When I confirm, it now calls that runtime 2, bank runtime 2.ecosystem.ai. If I go to bank and I go to laboratory APIs, and I look for runtime 2, and I pick spend personality score, there's customer 590. And if I execute that API and I look at its scores, you can see here that there's the score, 0.4 industrious, all the other parameters of the different variables are set. Here's the payload that somebody is going to call. It will do it in typically 2-3 milliseconds a shot, so you can call it at scale, even with fairly limited infrastructure. And in a GPT, it then shows you what those results are. Okay, so in this case, at round 4047, let's check what those. And if you want to know what the results look like, it should be, no, not this one. Let's do this example, spend personality for customer 851. And then we'll compare them, and I'll show you how it keeps the memory on the environment so that you can see what the scores are that can then be used for graphing. Okay, so now it does it for customer 851. It doesn't show the overall score, it only shows the individual scores. And then I can say, well, I'll compare these customers with, oh, they had already, let's say, yes. It already asked me if I want to do a radar diagram. And then you can see it writes the program in line for you with the score. So that's this kind of capability that can now be used, that just generic generative tools are kind of accessible easily because you've got the entire backend pre-prepared, pre-configured to do all the backend kind of work for you, including how you would, configure an environment. So yeah, oh, it's made its own mistake. So OpenAI is fixing it. This is running 04 mini. Maybe that's why. It's made a mistake again. We'll keep on attempting it until it has fixed it. It will try and find, let's see what it finds now. It's going to try and fix it again. It rewrites the program. Another mistake. So you'll see that if we take the same case and rerun it, you probably will see that it will do it right the first time around. But anyway, this is just because I've turned this setting on so people can see what it looks like, and there it's plotted onto whatever diagram you've done. So that means the architecture of gaining access to your runtime pods running permanently in a cluster that can scale horizontally and accessible entirely through a headless, so you can call it from anywhere, and then the ability to run it through the workbench to test everything. The workbench is not consumer-facing, it's partner-facing, so a partner configures their projects in here. So that this is bank. If you go to all the projects that are configured in this environment on the dashboard, you see these are the ones currently sitting in here. If I go to, let's say, me, you'll see that there are different criteria with a different set of cases that people can then gain access to depending on how they want to use that. But there are different scenarios for applying different configurations depending on what those configurations are.
You mentioned something about a demo environment.
Yes.
Would you mind sharing that URL?
If you go to ecosystem.AI and other products, this install, when you click install, you'll see that there are a variety of options to install the product. It could be AWS. If you go to deploy AWS, you'll see there's a whole ecosystem environment that you can access. If you go to Azure, it's the same thing for Azure with different cases that are accessible. If you go to run locally with Docker, it will take you to the developer site that I kind of showed earlier. If you go sign up for non-commercial license, you can use the prediction as a service platform that we provide. So once you've signed up, you sign up here. There's a process to sign up. And once you signed up and you then want to sign in, so let me just sign in with Jay. You'll see that I've got no instances running at the moment. We've got a finite amount of clusters available. If they're all taken up, you have to wait until one becomes available, or when we upgrade infrastructure. If I go to create an instance, let's say I now select, you can see there's some infrastructure available for me to use in this current configuration. So let's say I want to pick an M4, because I like M4s. And now what I want to do is pick a module to try out and test. I'm interested in intelligent sales that we've been working on. So I pick intelligent sales, set up my environment, and I give the sample user, Joe at ecosystem.AI, give it some kind of password for your exercise. The non-commercial license apply for this. So you have to say accept, and then your button kicks it off, and it gives you an outline of what you selected. Then you go create. Now it will spin up the infrastructure for you with all of those settings. So we don't want to compete with cloud providers. That's why you don't set the finite settings of everything. The idea is to make it as simple as that. You must be able to go in there, click, 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 spin it up, run a module, run a test, export the module, shut it down. When you want to try it again, spin it up again so that you keep on pushing infrastructure back into the pool. You can use it to test what you're doing. This will take a little bit of time, maybe 4 or 5 minutes, depending on how long it takes to spin up the entire infrastructure that we can then gain access to. And you'll see here, there's the URL that was assigned. So this is just called instance 12, and you can then click on that when the cluster is running, click on that, and you'll be able to access the backend once it's up and going. So we've made it as easy as possible. If you go to the website, that's the place to go. Use prediction as a service is the concept. So PaaS in our world doesn't mean platform as a service. It means prediction as a service. We're trying to change the way that people see the story. But you will see here, if you click on logs, you'll see that I've done more than 100 pages of spin up and start up and recreating and terminating. We've done a fair amount of testing on this environment. It's probably not fully commercially robust yet. So that means that's why we want to make sure that it's used for non-commercial and experimental purposes. We're not going to sell to native cloud capabilities from a access backend point of view.
We can get all the info we need from your website.
There is a lot of content there. On the prediction platform, there's a full description of most of the capabilities that are accessible, including these short videos that our team has been creating to make sure that it explains almost like an explainer. It's not just generic marketing messages filled with adjectives. It's got verbs in it as well. It'll guide you to take certain actions. The module store comes from our server. These are the actual modules that the PaaS environment has access to. The one I selected earlier is intelligent sales. If you select it, it'll tell you that there are more than one version available. If I pick that version, the description of that module, including its typical base requirement if you want to run it out of the starting blocks. You'll see at the moment this fact sheet will take it into the website to explain what this module is all about. And when you download it here, you'll see that there's a username password. When you're a partner of Ecosystem, you get the username password for this. So yeah, if it's just somebody coming off the street, then they can't access it. So you won't be able to gain access to these modules. Because you might want to run as a partner this infrastructure in your own cluster or in your own environment, and you just pull the module and you can install it there without manually installing the modules. There are more than what's here. We are working on pushing them onto this environment, so that's under modules. And then if you go to solutions, you'll see that almost all of these are pre-built modules with additional details. And in some cases, I'll show you in a moment what it looks like. You're going to see that it's more than just a marketing story. So here it explains to you how you build it, what you do. It shows the concepts of everything that is available to you in a fairly explanatory manner. If you go to spend personality, you see that there are a few extra options here. So this also has all the detail and an explainer video, including explaining to you how some of the details work. It pushes you to the custom GPT. So that means on OpenAI that you can access for the money personality if you want to use it. It also has an option called Get Your Score. We've got, for this particular module, a supporting website that can start collecting quiz data and then call the backend scoring engine. So this, again, an example of how that can be used, because this could be created by, you probably want to use your own question answer, or if you want to run it in Microsoft, because we've got also a Copilot assistant. But in Microsoft, you can drop our Copilot engine in and access the backend, like an example, like a spend personality or something. So that means the modules have access to a lot of the detail. And then under resources, you'll see custom GPTs. All the primary ones that we think are useful are here. Value proposition, use case designer for you to fill out your entire business requirement case. Recommender systems, if you want to learn more about it, we've got a lot of academic content there that is vetted by us, including our own. Developer documentation through our website, client pulse responder. So all of these are essentially accessible then publicly under the GPTs. Product tours will just put you to YouTube. And the team have now started indexing. I think that this is in the new series, just if I'm correct. So the idea is that we want to get it to a point where people can find out how things work and go look at the detail. And then you have documentation, developer site, and the blog. The team works continuously on blog entries. So there are a whole bunch of content that is written. So like here, how to spend make financial wellness a win-win. And you see this written by Nicola. But all of these are accessible for people publicly. Then we have a handful of white papers that explain a fair amount of the detail that if you're a partner, you might want to take some of our marketing and other presentations, and obviously that get bolted into your own, depending on how you want to use it. Eventually, you can start attending these sessions. We've got a series of calendars that show what's coming up in a particular series. The website is fairly complete, including the developer side, so you'll be able to get most of what we're kind of working on that we want the public to know about on those sites.
Very nice. I found it entertaining.
All right, amazing. Thank you so much.